I built this InstaDocs AI agent, which is intelligent AI powered knowledge based agent. Actually, InstaDocs solves a common problem when you have a tons of internal documents across like PDFs, texts, or Word documents or README files. Then finding the right information quickly from that all the documents is nearly impossible, right? So with the InstaDocs, you can ask questions in natural language to the model and get instant and accurate answers pulled from whatever document source you provided, right? So these are the basic requirements of the InstaDocs. User need to have a capability to upload the document and process the document. Processing is basically embedding into the vectors, and then user will give user will give ask the questions in natural language, whatever that is the English, and then user wants AI generated intelligent answers using a RAG pipeline, and that answer is complete answer or some information is missing or some AI is uncertain about the answer that should be provided, and then output should be in some JSON format so that we can analyze that, and there should be a feedback system so that user can give the feedback, and on that basis we can improve the system. Okay, so you can see the architecture of this InstaDoc. It is a very simple actually. When user will have some UI interface using a Streamlight, we did that for a demo purpose. And once user will put some inputs, then Fast API backend will call the RAG pipeline, and RAG pipeline will fetch some vectors from the ChromaDB on the basis of whatever the query user asks, and then that is serving as a context to the LLM and return back a response to RAG pipeline that will return back to the user. Okay, so what trade-offs we did is like we choose ChromaDB as local DB for vector storage, and local file storage as we don't have that much time, and then we use a local hosting instead of the deploying on some servers, and as we have only one DB and one server, so it is a single point of failure that is not having any backup mechanism and all due to time constraint, but in the production we should take care of these things. Okay, so we will start how to execute it and all. Okay, so first of all there will be a front end PS1 script and run backend PS1 script. So first you need to run backend PS1 script, and once it is started, you can see that we have the Open API uh, and Gemini API given to the system. So there is a fallback mechanism we added. So if there is a no Open API key, and if there is a Gemini key, then Gemini API you can use for LLM. Okay, and we will store some feedbacks and all in feedback JSON file for local purpose, and then you will start a front end. We use a Streamlight for a demo purpose. So once you started both, you can see this platform where you can ask the questions, you can browse the files, you can upload the documents. I will show you a sample. Suppose this file I gave, similar file I gave. So this is actually a knowledge base which I got from the Kaggle. which is actually IT related knowledge items, and all stuff is there about how to configure mobile devices and all that is there. Okay, so it is processing a document. You can see it is processing document. In the back end you can see that it is processing in the chunks. It is converting to the vectors, and then it will store into the chroma db. Once this all is happen, it's like 620. It's converted into 1300 chunks actually. So for the chunking, uh, we are using 800 per chunk. I'm using. You can set this according to your needs. Yeah, and here you can see embedding is happening, all initialization of the vector DB, uh, and then what is the collection name and all, and which is the similarity type you want, that you can mention here. And then open API, if you want open API based embedding, then you have to give the open API key, otherwise there will be sentence transformer. I'm using the sentence transformer, and this embedding will be generated in here. You can see embedding model, it will encode to numpy list. Okay, yeah, and now you can see that this all documents got processed. And if you want to ask some question, I'll ask a question on the basis of this whatever this data set provided. So there is this mobile device setup company for company email. So I'll ask how to set up mobile for company email. Okay, once I ask this, it will convert into some vector, and then it will match using cosine similarity search. Vector db will give some documents, and that documents will serve as context to the LLM, and LLM will generate some good results out of it. Here you can see that it gave a nice steps, prerequisite setup steps, or to set up the email and all. And then I added some query ID, confidence of this particular answer. If it is incomplete, the status will incomplete, complete. That status I'm maintaining based on this confidence. And then what is the reason of that it will give, and what source it used, that information, what is file it used, that it will give. And then missing information, like configure email settings and all these instructions it missed. And if some enrichment, then this enrichment suggestions the model will give. And in here you can see that you can rate this answer. We can improve this by providing email configuration settings. Okay, once you gave this feedback, it will store the feedback, and you can see in the statistics, in the statistic, the feedbacks will be calculated, like total 4 feedbacks till now I gave, and what model it used, what is the status of that model, what is the embedding model used, and what collection is there, and what is the feedback user provided, that I'm storing here. and then any improvement suggestion that will come here. So this way this model will work. uh, Thank you. Thank you very much.